we'll start today with the discussion of the worksheet 2 problems. So let's start with question number 7. If anybody has a doubt in anything before question 7, please message me, or please let me know. I will start with that then. As of now, question 7 is the earliest I have received. Okay, so let's start then with question 7. I'm assuming before 7 everything is clear. Okay, so in 7, you have two vectors of magnitude 10 each at an angle of 60 with respect to each other. Angle made by the resultant vector with respect to the first. Okay, so basically it is application of triangle law. So as you know, in general for triangle law, you know that if two vectors are placed like this, okay, this is vector A and this is vector B, and the angle between them is this one theta, then in this diagram the resultant vector becomes this one, and the angle that the resultant makes with the original vector E is this one. So for both of these things, as you know, you have the formula that magnitude of the resultant is given by this formula, root of E square plus B square plus 2ab cos theta, and the angle is given such that tan alpha is equal to B sin theta upon E plus B cos theta. So this is the triangle law as you know it. So in question 6 and 7, the information given to you is that for question 6 and 7, that magnitude of E and magnitude of B are both equal to 10, and the angle between them is 60 degrees. So you have to find the magnitude of the resultant, that is the 6th question, and you have to find the angle alpha, that is the 7th question. This is question 7, this is question 6. So since you've asked this one, let's start with this. Okay, so right, that is the question, 60 degrees. Okay, so you just apply this formula now for this question. Just substitute these values and apply this formula. That is one way of solving it. So to find out this, you just apply this formula here. In this, you substitute these values. So when you substitute these values, you will get tan alpha is equal to B sin theta. So that is B sin 60 divided by E, which is 10, plus B cos theta, which is cos 60. So that will become 10 multiplied by root 3 by 2 divided by 10 plus 10 into half. So as you can see, that will become 5 root 3 in the numerator divided by 15 in the denominator. So that is root 3 by 3, or we can write that as 1 by root 3. Okay? So tan alpha is equal to 1 by root 3, which means alpha is what we say is tan inverse of 1 by root 3. So that you know is 30 degrees, or you can also write it as 5 by 6, whichever is given to you in the options. Okay. So this is the simple, straightforward way of doing it using triangle law. I'll also show you another trick for doing this question, but first you can go through this and make sure this is clear. Okay, people, so hope this question is clear. Has anybody tried this by some other method like component method or anything? Because it is easily solvable by component method also. So that was the trick method I was telling you. We can also use component method. Though it's not necessary over here. It's quite an easy thing. So a couple of more tricks I'll show you. Another thing we could have done in this question, we could have used geometry. Alternate method. So in that, when we are looking at A plus B as a vector, yeah, it's quick only, but I'm showing you just some variations. I'm showing you is equal to 10 and theta is equal to 60 degrees. Yes, you're right, Dushan. This method is very fast, so there's no problem with it. The first method we discussed, okay. But I'm just showing you that there are some more interesting ways of also solving the question. And there's something like this. So this is 10, and this is also 10, and this angle over here is 60 degrees, okay. And in this is the resultant vector, E plus B. So now you can see that this happens to be what type of triangle? It's an isosceles triangle. It's an isosceles triangle. So we can make use of the fact that since this side is equal to this side, okay, so therefore this angle will be equal to this angle. Okay. And we'll use the thing that sum of interior angles is equal to opposite exterior angles. So that is 60 degrees. Okay. So this is the fact that sum of interior angles is equal to opposite exterior angles. Okay. Sum of two interior opposite angles is equal to that property you're using. So immediately you're getting alpha is 30 degrees. So that's done. And now once you've done that, you can do another thing, that if you drop a perpendicular from this side onto this side, it will bisect it into two distinct triangles, congruent triangles, where this side is x and this side is x. So for each of these triangles, if you use trigonometry, so it's a right angle triangle. So in that, what is happening is x upon 10 is equal to cos alpha. So x is becoming 10 cos alpha. So that is becoming 10 cos 30. So that is 5 root 3. And therefore, magnitude of A plus B, or the resultant, which is 2x over there, which is becoming 10 root 3, which you would have got by triangle law. But here you can apply this nice trick of geometry. Okay, so this is the geometrical method of solving this. Okay, Arvind, I'll show you the first diagram once more. Okay, the original diagram was not particularly for this question. It was just application of triangle law. Now, इस diagram में मैं क्या implement कर रहा हूँ? मैं implement कर रहा हूँ इस particular question के values को. The mod A is equal to mod B, which is 10 each. That's how I'm getting this diagram now. Okay. So in this original diagram, I'm now implementing the fact that magnitudes of A and B are same. So that is becoming a isosceles triangle. So therefore, this and this opposite angles are becoming equal, because mod A is equal to mod B is equal to 10. Okay, so hope this method is clear to all of you now. Okay, now next we will go with question number 8, because that has been asked. Okay, in this, if you wanted to find mod A plus B by triangle law, you would have used this formula. Mod A plus B for these values would have become root of 10 square plus 10 square plus 2 into 10 into 10 into cos 60, which is half. So you would have seen that it would have become 100 plus 100 plus 100. So that would have been square root of 300 or 10 to 3. Okay, so this is your answer to the sixth question. This question 6 is answer. And question 7's answer is for the same data, you have to find out the angle. So that is question 7's answer. And this is the alternate way of solving both of these using the isosceles triangle property. Okay, so hope all these different tricks and methods are clear to all of you. Now moving on to question number 8 next. Now 8 is a question that you can do in a similar way. The only difference is that the magnitude of A and B is not given, but it is given that they are equal in magnitude. 6th और 7th में magnitude not only equal था, उसका value दिया हुआ था 10. 8th के case में that value is not given. It is just given that mod A is equal to mod B, and the angle between A and B is 120 degrees. So theta has changed from 60 degrees to 120 degrees. Okay. So now we have to decide on which of the options are correct. So the options are basically about what is mod A plus B. We have to find that. Okay. So what's happening here is let's take mod A equal to mod B equal to some unknown value, but they are equal, so they are x. And theta is equal to 120 degrees. So mod of A plus B, we can directly substitute this way. It is root of A square, that's x square, plus B square, that's x square, plus 2 times AB. So that is 2 times x into cos 120. So this is what we have to solve now. Now you know that cos 120, second quadrant, so we will write it as minus cos of 180 minus 120, or minus cos 60, or minus half. Okay. So we'll substitute this thing here as minus half. And doing that substitution, now you can see we'll get this as root of x square plus x square plus 2x square into minus half. So that will be minus x square. So that will simply become x. So you can see that therefore ultimately what we are getting is that mod of A plus B is the same thing as mod A, is the same thing as mod B, which is equal to x. What we are saying. Okay. So in this question, don't need to really do anything else, even though this also has a very easy geometrical solution. अभी इसमें भी आप सोचिए geometrical solution और भी आसान है. But इसमें if you draw the triangle, you will see you get an equilateral triangle. Yes, exactly, Tushar. Okay. Equilateral triangle का ये exterior angle 120 होता है और दोनों side equal होते हैं. In fact, तीनों side equal हो जाते हैं. So you apply that same logic over here. Okay. So you understand that here is like this. Whatever is E's magnitude, suppose x, B's magnitude is also the same, it's x. So this side is equal to this side. Okay. And in addition, this angle is how much? It is 120 degrees. Okay. So the resultant is this one, such that now you can see that if the resultant, which is A plus B, is making some angle alpha here, because these two sides are equal, now this angle will be equal to this angle. Okay? So alpha plus alpha this time is theta. So 2 alpha is 120 degrees. So alpha is how much? It is 60 degrees. So that means the moment these two alphas are 60 degrees, it is not only isosceles, in fact it is an equilateral triangle. Okay. And therefore magnitude of R is equal to magnitude of B equal to A, which is x. So that's yes, Aditya, I'm coming to those questions. Thanks for No, don't worry. Okay. We will be covering question 13, 14, 15 very soon. Okay. But before that, we also have to discuss question 9, 10, and 11, which have been asked separately. So, like, make a note down of this and next move on to question 9. So question 9 is a little bit about inequality. Let's understand this. Okay. So it says that two vectors A and B are at an angle of 45. Then which of the following is correct? So vectors A and B are at 45 degrees to each other. So then what we can say about magnitude of A plus B? It will become the root of A square plus B square plus 2AB cos 45 हो जाएगा when you substitute this. So that will become the root of A square plus B square plus 2AB into 1 by root 2. So that you can see is root of A square plus B square plus root 2AB. Now how I can compare this with A plus B? So I can see like this. This is definitely, if I compare with A plus B, I can write A plus B as square root of A plus B whole square. So I can write it as the root of A square plus B square plus 2AB. और अभी इसको कंपेयर करो इससे. So you can see that as far as this quantity is concerned and this quantity is concerned, it's definitely less. Okay. So that means this quantity is definitely less than this. So it's less than this. So therefore, you can see that mod of A plus B will be less than mod A plus B. Okay. Or you can just use the statement of triangle law directly. Okay. If you understand the triangle inequality, directly you can use the triangle inequality. Where you can understand that triangle inequality का statement क्या होता है, that mod of A plus B for any possible value of theta is less than equal to A plus B and greater than equal to difference of A and B's magnitude. But when is it this? Okay. Where we understand mod of A plus B is equal to mod A plus mod B only for theta equal to 0. Okay. Therefore, any theta not equal to 0, what will happen? Mod of A plus B will be less than mod A plus mod. So we could use this directly. We could have directly used this, that if it is given to us that theta equal to 45 degrees, we know that it comes in this category. It doesn't come in this category. So we didn't need to do all this calculation also. नहीं, दुष्यंत क्या होता है ना कि vector doesn't have a value. Vector has a magnitude and it has an angle. So magnitude of a vector cannot be a negative quantity. Magnitude of vector is not given with algebraic sign plus or minus. Component of a vector can be negative. Okay, but the magnitude of a vector cannot be a negative quantity. Mod of a vector is it's a magnitude. Okay. So it does not have sign. Does not have algebraic sign. So we cannot say it is positive or negative. It's just a magnitude. However, if we are writing a vector as components, ax I cap, ay j cap, like this. Now ax can be positive or negative. Ay can be positive or negative. So components of a vector can be positive or negative. Okay? Components have plus or minus sign both, or can be 0 also for that matter. Okay. but the vector itself we can't say whether it is positive or negative, because by vector what we generally mean, what is the value of the vector? We mean, I mean, first of all, it's not a technical statement when we say what is value of a vector. It's like everyday language. The technical statement would be that we are saying what is the magnitude of a vector. So magnitude of a vector को हम कभी algebraic sign नहीं देते कि plus या minus. ठीक है? Hope that point is clear, Dushan. Yes, Dushan. Hope that point is clear, beta. Okay. Good. Now let us move on to question number. We are done with 9, right? And 10 was not asked. 11th was the next question somebody has asked me. Oh, 10th has also been asked. Sorry. 10th and then 13th. 11th also. Okay. Okay. So let's come to question 10. So let's see what's happening here. So question 10 में कह रहा है resultant of two vectors A and B is perpendicular to E and has a magnitude of double of E. Then we have to find the ratio of E and B. So if R is the resultant of A and B, that means it's the resultant, is the sum of A and B. Okay. Now it's given that this R is a vector such that it is perpendicular to E, okay, and its magnitude is, what is it now, twice of E. Yeah, twice of E. So we have to find the ratio of magnitude of A and B. Okay. So it's very simple. We can either do this geometrically, we can draw the vector triangle for this. Okay, so you can see that this is the vector E, then the vector B must be something like this, so that the resultant sum of A and B is becoming perpendicular also, and also it is becoming twice of E in magnitude. So this is the resultant vector E plus B. It is having a magnitude of twice of E compared to this vector A over here, which has magnitude E, and this vector B, whose magnitude we don't know. Okay. So now you can just see from the right angle triangle, B will be equal to square root of R square plus A square. So B will have a magnitude of square root of this. Okay. So B will be E root 5. So from this you can see that E by B will be 1 by root 5, or magnitude of E, ratio with magnitude of B will become 1:5. Okay. So this is one very straightforward way of doing this question, which I think is the simplest way of doing the question. We can also do this, I think, pretty easily by component algebra also. So you can try that out also. So next, after you understood this, also try this by component method. Also try by using component algebra. Let's see what we get if we do that. Okay. Just try this out. Okay, so people, yes, some of you must have got this by component algebra also. By component method, what we can do is, since it is given to me that R is perpendicular to E and R has a magnitude which is twice of E, let A be along the x-axis. That is, the x-axis is along vector E, and therefore the resultant becomes 2A j, because the y-axis is along the result. Basically, what we are saying is that, let's say, whatever the direction of the vector E, that only I have selected as my x-axis, and whatever is the direction of the resultant, is 2A in magnitude, that is becoming the direction of my y-axis. Then what is happening? I have a resultant which is equal to A plus B is equal to 2A j cap, and vector A was AI. So now if I subtract these two equations, I'll get the vector B. So equation 1 minus equation 2 will give me the unknown vector B. Give me B is equal to, on this side I'll get 2A j cap minus E. So now from this you can see that the magnitude of vector B will become root of x component square plus y component square. So you see that magnitude of B is A root 5. So same thing. Now again getting from this that ratio of A is to B, 1 is to B. So component method is also very feasible. My question is, okay, use it as a general method of solving anything like this. So in vectors, mostly we always have an option. In most questions, there's always an option that we can either go with component method or by the geometrical method. Okay, so Dushan, hope your doubt is clear with this now. Because B is along the y-axis. Okay. So the resultant is along the y-axis. So by subtracting these two equations, immediately we come to know B ka ऐसा है. So what is Bx? Bx is minus. What is By? So therefore magnitude of B is root of Bx square plus By square. That is becoming root 5. Okay, so that was 10th question. Now moving on to the 11th question. So 11th question can also be done by a version of triangle inequality. So in 11th question you can see it is given to you that magnitude of A is 12, magnitude of B is 16, and the angle between them is obtuse. So obtuse means जो भी angle है इनके बीच, it is greater than 90, less than equal to 180. So what does that mean? That cos theta is less than 0, greater than equal to minus 1. Cos theta can't be 0 also. So therefore you can immediately see that magnitude of A plus B will become less than root of A square plus B square, because it can't be this, okay, but greater than or equal to difference of A. That means magnitude of A plus B will be less than root of 12 square plus 16 square, but greater than or equal to the difference of 12 and 16. That means that magnitude of A plus B cannot be 20 also, it is less than 20. At the same time, it is greater than or equal to 4. So it can be 4, but it cannot be 20. It can be anything between 4 and 20. So this is basically coming from just applying the condition of obtuse angle on the formula that mod of A plus B is root of A square plus B square plus 2AB cos theta. So अब देखो cos theta का minimum possible value क्या है? -1. So mod of A plus B का minimum value कितना होगा? नहीं, -1 नहीं होगा. It is always magnitude of A and B. See, if you substitute in this, you substitute A as 12, B as 16, and theta is 180 degrees. What will you get? You will get square root of 12 square plus 16 square minus 2 into 12 into 16. So that is square root of 12 minus 16 ka whole square. So that is 4. The magnitude of a vector cannot be negative things. That's the point. It always comes without sign. Understood the point? क्योंकि अगर मैं कहता कि अच्छा -4 तक हो सकता है तो 0 भी हो सकता था, because 0 is greater than -4. But can two displacements of 12 and 16 give you a resultant of 0? They can't. That is the whole point of it. Is less than 90. Less than equal to 180 but greater than 90 because it is given to us as obtuse. This is given to us in the question. This is given in the question. So obtuse का मतलब ही वही होता है that it can be greater than 90, but it has to be less than equal to 180. 180 is also an obtuse angle. 90 will not be treated as an obtuse angle, but 90 से थोड़ा सा भी ज़्यादा हो, like 90.001 is also an obtuse angle. Like that 179 is an obtuse angle, but 180 is also an obtuse angle. So obtuse का definition ही यही है. This inequality is the definition of an obtuse angle. Okay, so that is this question. Now I'll move on to 13th question next. So, hoping all of you got the 12th question. In 13th, if I remember, there is a correction in the answer key. I'll just verify and tell you. But let's go through the question first. Yeah, so in 13th question, they are saying that we have three vectors F1, F2 and F3, or rather three forces of 100, 80 and 60 acting on a particle. Then the angle between F2 and F3. So F1's magnitude is 100, F2's magnitude is 80, and F3's magnitude is 60. And given that the resultant of the three forces F1, F2 and F3 is 0. This is in Newton's. You have to find the angle between F2 and F3. Find theta between F2 So now the thing is, this is how we solve this question. So since resultant of the forces is 0, or in other words, F1 plus F2 plus F3 is equal to 0. Okay. Yes, it's a 3, 4, 5 triangle, correct? So we can say that F1 is negative of F2 plus F3. Okay. Or we can say that F1 has a magnitude which is equal to mod of this. So we can say that F1 is equal to mod of F2 plus F3. So that is equal to, by triangle law, F2 square plus F3 square plus 2F2 F3 cos theta. Okay. Now given this was 100 and those were 80 and 60, so just substitute. So 80 square plus 60 square plus 2 into 80 into 60 into cos theta. Now when you solve this, you get this result that 100 is equal to common, sorry, 10 common. You get 64 plus 36 plus 96 cos theta. So 10 is equal to square root of 100 plus 96 cos theta. 10 square is equal to 100. So you get cos theta equal to 0, which means theta is equal to 90 degrees. Yeah, the answer in this is not correct. There is an error in the assignment. So just make the correct answer 90 degrees. None of the options are actually correct. Actually, the options are okay. The question asked is wrong. What should have been asked is the angle between F1 and F2 rather than F2 and F3. I'll explain to you how it works. But first, just go through this solution. Now we'll also understand this geometrically. Yeah, F1 and F2 के बीच बेटा 37 की जगह it would have been 180 minus 37 because it's the exterior angle. So Anmol, if I ask the angle between F1 and F2, you will see it will not be an acute angle, it will be an obtuse angle. It will be that exterior angle of that triangle. So it will be yes, correct, Prince. Yes, exactly. We have to make it like this. That mod of F3 is equal to mod of vector sum of F1 and F2. So suppose you wanted to find for angle between F1 and F2, you have to do like this. That F3 is minus of F1 plus F2. So magnitude of F3 would have become mod of F1 plus F2. So now, for example, this is given to us as 60. That would have become mod of F1 plus F2. by triangle law, and from that you would have got cos theta, and from that you would have got theta. Okay. But since this is, the sides are like this, f1 equal to 100, f2 equal to 80, and f3 equal to 60. So f1 is to f2 is to f3 is 5 is to 4 is to 3. So they are actually a Pythagorean triplet. So we can use that to our advantage. Okay, that is 100 square is equal to 80 square plus 60 square. Therefore, f1 plus f2 plus f3 equals to 0 implies that they are forming a right angle triangle. Something like this. This is f1, it's 100. This is f2, this is 80, and this is f3, this is 60. So you can see the angle between f2 and f3 is 90. But on the other hand, you'll also see that this is a 3, 4, 5 type of triangle. So this angle would be 37. So the angle between f1 and f2, this angle, let's say theta 1, the angle between f2 and f3, let's say theta 2, and the angle between f3 and f1, let's say theta 3. So theta 1 would have been 180 minus 37, or 143 degrees. Theta 2, which angle we have been asked, that's 90 degrees. And similarly, theta 3 would be 127 degrees. 180 minus 53. Because this angle here would have been 53 degrees. Okay, so no prints, no such issue here. Just check your connection once. Okay, so this is another way we can do the question. So you can see that theta 1, the angle between f1 and f2 in my diagram is 143 degrees. Similarly, theta 2, the angle between f2 and f3 is 90 degrees. And theta 3, the angle between f1 and f3 is 127 degrees. So hope this question is clear, people, all of you. Right. So now moving on to the next question. This was the 13th question. Moving on to 14th question. In 14 now you can use a component algebra also very conveniently, or you can use triangle law. So question 14 has given you a diagram like this already, where you can see that you have a vector of magnitude 10, which is sort of along the negative x-axis like this. So this is some vector, let's say q or something. It's 10 along the negative x-axis. In comparison to this, another vector is given to us, which is of unknown magnitude. So this vector's magnitude is unknown. But we do know that with this axis, the one perpendicular to this one, or with the so-called y-axis, it's making an angle of 30 degrees. So what we can do is we can designate this direction as our x-axis and this direction as our y-axis. So if the magnitude of the vector, the unknown one is p, but the angle with respect to the x-axis is 60 degrees now, with respect to x-axis. So in that case, we can express the components as p by 2 and p root 3 by 2. So that way, in component algebra form, we can express the vector p as p by 2 I cap plus p root 3 by 2 j. Whereas vector q is directly known in component form. You can see that the vector q, it has a negative x component of 10 and does not have any y component. So now the condition asked in the question is that the resultant should be along the y-axis. So we can just apply that condition. Now, given that resultant of p and q is perpendicular to q, okay, so that means it is along y-axis. So let's just substitute this. Okay, so this resultant will be, now we are adding this vector with this vector. So it will become, the x component will be p by 2 minus 10 I cap, and the y component will be p root 3 by 2 plus 0, because this doesn't have any y component, j cap. So this should be along the y-axis. So if this resultant vector is along the y-axis, it means that ये जो resultant vector है उसका x component कितना है 0 और y component non-zero. So that means this x component, which is p by 2 minus of 10, should in fact equal to nothing. It should be null, so that it's only along the y-axis. So that is telling you that p's magnitude is 20, and therefore that the resultant is nothing but 10 root 3 j cap, whereas p in the component form would just become 10 I cap plus 10 root 3 j cap. But more importantly, p's magnitude is 20. Okay, so this is the easy way of doing this question using the component method. So we are using the component algebra method. So people hope this question is clear to all of you. Yeah, so friends, what's happening is this diagram was given to us in this question with an unknown magnitude vector p, but in a direction like this, such that it's making 30 degrees with the y-axis, whereas the other vector q is known, it's 10 in magnitude and it's along the negative x-axis. Now the question is asking for the magnitude of this vector, provided the resultant of p and q is in which direction? Perpendicular to q. That means along the y-axis. Okay, so what I'm doing is I'm making use of component algebra to express p in I cap j cap form and q in I cap j cap form. So q in this form is minus 10 I cap, because it's a vector of magnitude 10 along the negative x-axis. On the other hand, p, its components will be unknown because the magnitude is not known, but this angle is becoming 60 degrees with the x-axis, this one here. So whatever the magnitude p, the x component is becoming p by 2, the y component is becoming p root 3 by 2. So I can express the vector p in this way in terms of the unknown quantity, which is its magnitude. So I've got this vector p expressed in component form in terms of p, capital P, the magnitude, and I've got the vector q completely known, it is minus 10 I cap. Now I apply the condition that the resultant sum should be perpendicular to Q or along the y-axis. So in दोनों को add करना है. This particular vector and this particular vector, they have to be added in component form, and that resultant sum should have this property, should be along the y-axis. So next the condition becomes this. So if that resultant is along the y-axis, then its x component, which is p by 2 minus 10, should be 0. That's how a vector will be along the y-axis, right? It doesn't have an x component. So the vector's direction is directly along the y-axis. Yeah, you can do this geometrically also. But as I said, geometrically is a little bit more complicated. You'll have to use the tan 90 condition. Okay. So to do this geometrically, you'll have to understand that by triangle law, you have to understand that the angle between the vector P and Q is actually 120 degrees. Because this is 10. This angle is 30. So this is the vector P. Then what is the angle theta? The angle between the two vectors. That is this angle. Okay. So theta, the angle between P and Q, theta is equal to 120 degrees. Okay. So therefore, the condition for R to be perpendicular to Q is like this, that when we draw Q like this, we have to draw P like this. We have to draw them head to tail because we are making use of triangle law. So this angle between them is 120 degrees. P's magnitude is unknown, but it is known to me that the resultant is perpendicular. The resultant would be this vector here. So ये जो है क्या होगा, Q के perpendicular होगा. So alpha is equal to 90 degrees. So tan alpha, which will become P sin theta upon Q plus P cos theta, that will become P sin 120 upon Q, which is 10, plus P cos 120. So this should now be tan 90 degrees because alpha is 90. So it should be undefined. So next step, P sin 120 upon 10 plus P cos 120 should be undefined. So undefined means the denominator should be 0. It is 10 plus P cos 120. They should be 0. So 10 plus P into minus half. So this will now give you the required answer. So it's a little bit more complicated to do this geometrically. Easier to do it by component algebra. Okay, so this is a geometrical solution of it. The the condition that these two vectors, their sum is along the perpendicular. This condition. This condition applied to these two gives you this kind. Okay, so just take a look at this and make sure you understand the working. No, but then see what is asked now. What is asked is not the magnitude of P. What is asked is the magnitude of the resultant. So the magnitude of the resultant is becoming how much now? That is becoming 10 root 3 because that is see the resultant. Or if you're doing by this method now, you'll have to understand from this right angle triangle that this resultant will become square root of P square minus Q square. So now that will become. Or you can apply tan 30. That's good. Tan 60. You have to apply. Okay, so hope this is clear, people. The question is actually asking for the magnitude of the resultant. So you have to apply this one. Okay, so let's move on to the last question of the worksheet. Now this is a little bit of a complicated question, so I'll explain in detail. So P and Q are two vectors of magnitude such that mod P is to mod Q is 1 is to 2, and the resultant is at an angle of tan inverse root 3 by 2. Then we have to find the angle between P and Q. So let's understand what this means. So don't worry, once you understand the meaning of this question, you will find it easy enough to solve. Just initially the language might have put you off. Okay. So P and Q are such that magnitude of P is to magnitude of Q is given to us as 1 is to 2. Okay, that's one thing given. And if the resultant P plus Q, okay, makes an angle alpha with respect to P, then alpha is equal to tan inverse root 3. That means that tan alpha should be equal to root 3. This is the meaning of this statement. The resultant makes an angle of tan inverse of root 3 by 2. Let me write that more properly so that you won't get confused later. Tan inverse of root 3 by 2 with respect to P. So ये जो statement है इसका मतलब ये है. This means this, that if the resultant defined by P plus Q makes some angle alpha with respect to P, okay, then that alpha is equal to how much? It is tan inverse root 3. Okay. So now let's convert this to a diagram and understand what this means. In terms of diagram, it means that if this is the vector P, the vector Q would be something like this, larger in magnitude. So ये अगर x है तो ये 2x and this angle is unknown, but whatever the resultant is, it is such that it makes an angle of tan inverse this angle. So given that P is to Q is 1 is to 2, that we already taken care of, and alpha is equal to tan inverse root 3 by 2. Or in other words, tan alpha is root 3 by 2. Okay, this is what we have to apply. So now which formula will apply for this? Apply that formula, triangle law formula. Apply triangle law formula for tan alpha. Tan alpha is, in this case, Q sine theta upon P plus Q cos theta. So apply this formula to this triangle and you will understand what to do. Apply this formula over here, that this thing is this. Whereas if P is x, then Q is of magnitude 2x. So apply that also and you'll get the answer. Okay, just try this out now, people. So मुझे ये सब substitute करके क्या निकालना है? I have to find out theta. We have to find okay. So saying that so friends, what is happening is if I make the statement that alpha is tan inverse of something, let's say some number n, that basically means that tan alpha is equal to n. Okay, that is the meaning of this statement. So for example, if I say that, let's say beta is tan inverse of root 3, that means that tan beta is root 3. So that means that beta is nothing but 60 degrees. This is how we solve this. Okay, so have you understood that, friends? Okay. Now still a lot of work has to be done in this question because this equation has to be solved for theta, which is not easy because that equation has a sine theta term and a cos theta term. So while solving the equation, we will have to use some kind of trick. Okay. So substitute this now. So tan alpha is given to us as root 3 by 2, and on the other side that is equal to q, which is 2x sine theta upon p, which is x, plus q, which is 2x cos theta. Okay. So from this we have to find what theta is. So let's see how we proceed here. So as I told you that these type of equations are a little tricky in maths, how to solve. So first thing is cancel the x. So this is becoming root 3 by 2 is 2 times sine theta upon 1 plus 2 times cos theta. Now next what we do is square both sides. Okay. So we will get 3 by 4 on this side is 4 sine square theta upon 1 plus 2 cos theta ka whole square. Now in this we will use the identity that sine square theta is equal to 1 minus cos square theta. Not x but theta. So that is the trick we'll be using. Sine square theta plus cos square theta is 1. So we can replace sine square theta as 1 minus cos square theta. So we further get this equation. It's 4 times upon 1 plus 2 cos theta the whole square. So now we will solve this for the value of cos theta, so that from that we can get theta. It's a quadratic equation in cos theta, you can see. We just cross multiply. So 3 times 1 plus 2 cos theta the whole square will become 16 times 1 minus cos square theta. So this will become 3 times 1 plus 4 cos theta plus 4 cos square theta is equal to 16 minus 16 cos square theta. So this should also be a theta, not an x. So next, take all the terms on one side. So you see cos square's coefficient will become 4 3s are 12 plus 16. So that is 28 cos square theta. Then we have plus 12 cos theta. And then we have 16 minus 3. So that is plus 13 is equal to 0. Okay. Now we solve this as a quadratic equation for cos theta. So just take a note of the steps up to here first. Okay, now we'll solve this for cos theta and we'll get the answer. Sorry, my mistake, this is minus 30 plus 30. Okay. So now you can see that this will become cos theta is equal to minus b plus minus root of b square minus 4ac So you can see that this you can take you can write that as minus 12 plus minus 4 times square root of 9 plus 91 by 56. That is minus 12 plus minus 40 divided by 56. That will become either 28 by 56, which is half, or minus 52 by 56. But here we can see that cos theta is a positive quantity. So therefore, cos theta is half, meaning theta is 60 degrees. So the last part of the solving is a little lengthy in this. Just given for your practice of quadratic equations and all this. Okay, so just go through this carefully and make sure you understand the steps. Yeah, Kushi, it was minus 13. Thanks for pointing out. So hope the solution is fully clear now. Yes. Okay, the final step. Yes. Okay, people, so hope this is clear. So this was a calculation heavy question. Okay, don't worry. One or two questions are going to be lengthy like this, just to test our patience and ability to calculate. Tricky part in this was not so much vector algebra, but the solving of the equation. And in maths, you will do plenty of these type of trigonometric equations, so don't worry. Okay. Now moving on to the next thing about vectors, which we'll learn, is components in 3 dimensions. In a 3-dimensional Cartesian coordinate system. How to express this thing? Let's understand. So first of all, let us understand a 3-dimensional Cartesian coordinate frame. Let's understand this thing. So it consists of x, y, z axes, which are mutually perpendicular. That is the meaning of a 3-dimensional system. So this mutually perpendicular actually means that x is perpendicular to y-axis. Y-axis is perpendicular to z-axis. And x is perpendicular to z-axis also. So any pair of axes are perpendicular to each other. Okay. So the best way to visualize this is like this, that imagine like this. So imagine a situation where just a moment. Okay. So this is actually, just imagine this to be the floor of the room in which you are sitting. This is the floor. Okay. And this origin point is one of the corners of the room. Okay. And this one is the wall which is right in front of you. This is the wall to the front of you which you are sitting. And this one here is the wall which is to your left hand side. On your left side. Okay. So now you can understand how the axes are mutually perpendicular. You understand first prints. Okay, don't worry about writing the notes. Okay. I will give you time to write the notes, plus I will send you the whiteboard notes also in PDF, so you can later fail the notes out also. Right now, it's more important for you to understand what is XYZ coordinate system. So the first thing is I want you to be able to visualize. Okay, so this is a way to visualize 3D coordinates. Think of this as the space, the three-dimensional space of the room in which you are present. Okay. So now take this corner origin over here is one of the corners. Okay. It is basically your front left bottom corner. In front of you, the bottom left corner which you are seeing, that one is. Okay. So it's a corner between two walls. So the origin here is basically, it is a corner between two perpendicular walls, okay, and the floor. Okay. Which perpendicular the walls? The one in front and left side. So you see a wall to the left side of you, right? So you are seeing a wall to your left side like this. The camera a little bit better. Yeah, so to your left side, you are seeing a wall like this to your left side, and you are seeing a wall in front of you, right in front of you. So ये दो wall और floor यहाँ पे intersect कर रहे हैं. So you are sitting like this. So in front of you there's a wall. To your left side there's a wall, and there's a floor below. So this corner of the room, where these two walls and this is meeting, the floor is meeting, that is your origin. That is this origin point of view. Okay. So the red colored surface that I've drawn, that is the wall which is in front of you. This is how you can visualize the three dimension. So this wall is actually acting like the XY plane. There's the vertical face of the wall in front of you. That's the XY plane. There is the wall which is to your left hand side. When you turn left, the wall that you're seeing on that side, or if there's a window or whatever, but it's part of a wall. That wall is becoming your YZ plane. And you can see that these two planes are perpendicular to each other. They're intersecting at this corner, this entire edge, which is perpendicular to. Okay. And similarly, the ground on which you're sitting, that floor, is represented by your XZ plane. So now you can visualize the axis. From the front left bottom corner, this edge, the edge between the wall in front of you and the floor, that is one of your axis, x-axis. Then the edge between the two walls which are perpendicular to each other, the wall to your left and the wall in front of you, that edge is your y-axis. So you can see these two are perpendicular to each other, x and y are perpendicular. and the edge between the wall on your left, right, and the floor below you, that one is your z-axis. So you can see that each of these edges is perpendicular to each other. So x-axis is perpendicular to y-axis, x-axis is perpendicular to z-axis, and y-axis is perpendicular to z-axis. So that is how you visualize the three-dimensional coordinate frame in a sort of three-dimensional space. Because ultimately, remember, see, we are just trying to create the illusion of three-dimensional diagram. Actually, I am making the diagram on a two-dimensional plane. I cannot construct a three-dimensional image like that, okay, because I don't have a hologram or something. Okay, but we are trying to visualize it by using the space in which we are present, which is the three-dimensional space, and that is how we visualize a three-dimensional space. Okay, so now you can note down the heading and this part. Give enough time. So next thing that we are studying is about this components of a vector in three-dimensional system or three-dimensional Cartesian coordinate system. So the first thing that we need to understand is what is a three-dimensional coordinate frame itself. Okay, and below this is how we understand the geometry of the mutually perpendicular dimensional axis. Okay, so this is the way we visualize the three-dimensional system. Yes, Dushant, I will be sending the notes on the group. Don't worry. So right now your understanding is more important. I will be sending the notes. Okay, so hope all of you are able to visualize in this way which I have written over here. Okay, people, so hope this is clear. Now, this takes some getting used to, so don't worry if initially it's a little tough to visualize. Now, I will give you another way to visualize three-dimensional space or three-dimensional coordinate system. Another method is very easy. Another way to visualize 3D coordinate axis. Okay. Just imagine you have a rectangular box, a cuboidal kind of box. Like this. this is a rectangular cuboidal box. It has 6 faces such that adjacent faces are perpendicular to each other. Okay. Now, in this box, visualize as if one of the corners is your origin. This corner is becoming your origin, let's say. Okay. And now each of these is your axis. So visualize this edge is becoming our x-axis. It's our positive x-axis. Similarly, let's visualize as if this edge is becoming our y-axis. And similarly now, this edge here is our z-axis. So they are mutually perpendicular, as you can see. And of course, opposite to your x-axis, you have the negative x-axis. So that is also there. These axes continue like this. This is your x prime axis. Okay. Similarly, this continues down like this. This is your negative y-axis or your y prime axis. And this continues like this. That's your z prime or negative z axis. Okay. So this is another way to visualize your 3-dimensional coordinate system. So the corner of this box is our origin. And 3 mutually perpendicular edges become the axis. And the 3 mutually perpendicular edges from that corner point which you have taken as the origin are the x, y, and z axis. So this is another effective way of visualizing a 3-dimensional coordinate frame. Okay, and further when we express vectors, you will see this will be very useful. Okay, people, so hope this is clear. So now we are coming to the part where we can express vectors in this kind of 3-dimensional system. So next thing we'll see is, just give me a moment guys, I need to restart the whiteboard program because it's running very slow for some reason. So I'll just reboot the program, just give me a moment. So now vectors expressed in three-dimensional component form. Now that we have understood, okay, the three-dimensional coordinate frame, so they are expressed in terms of unit vectors, or what we call the standard unit vectors. Or sometimes we also call them the base unit vectors. So because it's three-dimensional, now we use three of them. The unit vectors are I cap and j cap, same as what we used to use earlier. But now additionally there is also k cap. So this is a unit vector along the positive z axis. Just like this is a unit vector along the positive x axis. This is a unit vector along the positive y axis. So like that, these two we had already seen before, but now we also express the new one k cap, which is along the positive z axis. Okay. So just make a note of this point first. So we have three standard unit vectors which are mutually perpendicular. I cap, j cap, and k cap are mutually perpendicular. Okay, so once we have now expressed k cap also, next thing we'll see a vector in component form now becomes like this. This is how it is. Where Ax, Ey, and Ez are scalars, can be positive or negative, called the x component of vector E, the y component of vector E, and the z component of vector E respectively. Okay. So just one component is now added to our system. Just like in two-dimensional system, we had Ax I cap plus Ay j cap. Okay. Now in three-dimensional system, we have additionally Az k cap. Yeah, this is A subscript Z k cap. This last term. This is just added to our two-dimensional. You can write it like this also, it doesn't matter. You can write Z like that also. Okay, now the very important thing, that if we have expressed a vector like this, Ax I cap plus Ay j cap plus Az k cap, then what will be the magnitude of the vector? How will we express the magnitude? Like in 2D, we had seen it was square root of Ax square plus Ay square. So in 3D, how will we express the magnitude? Just think about this, I will explain. Yeah, so people, we are talking about how, yes, very good. Anmol, that is in fact correct what you said. So we will express the magnitude of this vector very interestingly as, you see that mod A actually becomes this formula like this. Now let's just try to, I mean, of course, this formula is correct on its own. There's no doubt about it. Okay, but let's try to justify this formula also. EQ as I am. If the three components are there, why it is root of ax square plus ay square plus az square? Let's try to understand this also. This is magnitude of vector E. हाँ मतलब क्यों करते हैं सर? Now if you think about it, there are a couple of ways of justifying this. So we can understand it this way, that if the vector A is axi cap plus ay j cap plus az k cap. Okay. Let me take the vector B as axi cap plus ay j. मैंने B को ऐसे define किया. Given this vector A, I've just defined B like this. So what is magnitude of the vector B? I can see it is square root of ax square plus ay square. Why this is the case? Because I know that I cap is perpendicular to j cap. So these two are perpendicular. Okay. And what is further happening? The vector A can be treated as the vector B plus az. Okay. Because I'm replacing this thing, okay, as the vector B. So over here, this thing is getting replaced as vector B. Okay. Now you can also see that vector B, it lies in the xy plane. So if you imagine that three-dimensional space, the vector B is lying somewhere in the on the wall in front of you, whereas ez k cap, this is a vector along the z-axis, okay, of magnitude az. So what is the direction of this az k cap? It is perpendicular to that wall. It's along the z-axis. So if this was the wall in front of you, okay, so this is your x-axis and this is your y-axis. So your vector E is lying, vector B is lying somewhere on this wall now. Vector B is somewhere on this wall. But what about the vector z cap or k cap? It is lying like this. This is your z-axis. So it is perpendicular to this wall. So your vector Ez k cap is like this. So it is at 90 degrees to this. Understanding? Because this is lying in the wall in front of you, and this one is coming out straight to parallel to this. Okay. So therefore, magnitude of the vector E should become square root of magnitude of B square plus magnitude of Ez k cap square, because they are perpendicular vectors, and you all already know that when two vectors are perpendicular to each other, then it's like a hypotenuse. So this is B square plus Ez square. Now B square is how much? It is ax square plus ey square. So magnitude of the vector E is becoming root of ax square plus ey square plus az square. So this is a very simple way of understanding that relationship between the components and the magnitude of the vector. So hope this method is clear to all of you. Okay, people. So hope this simple proof is clear to you. There are other ways of proving this also. Geometrically also you can prove. So for example, if you want to understand this geometrically, you can think of it like this, that suppose these are my mutually perpendicular axes. Now suppose I am using them to construct a box like I done before. Something like this. So I have this box. Now I have defined, let us say, this point in the box as my origin. Okay. And just a moment. So I have defined that point as my origin, and I have defined these as my x, y, and z axis. So I can define this as the vector, or this edge as of having magnitude ax. So this becomes ax I cap. So this is my x-axis. Similarly, I can define this thing now, I can define this thing as Ay j cap. Because this is my y-axis. Okay, and I can define this side as Az k cap. Okay. Because this is my z-axis. So individually, I can define Ax, Ay, and Az as the mutually perpendicular edges of a cuboid of dimension Ax into Ay into Az. This is the volume of the cuboid. So then you will see that within this, therefore the vector which is defined as the sum of Ax I cap plus Ay j cap plus Az k cap. If you want to understand what that vector is, you will see that it will become the body diagonal of that particular diagram. Now in this, if you want to understand what is Ax I cap plus Ay j cap plus Az k cap, so what you can do is, you can just give me a moment. Okay. Now within this, I want to do the operation of Ax I cap plus Ay j cap plus Az k cap. I want to do this operation to understand what the vector is. So from the origin O, here, I will start by making a displacement of Ax I cap. So I will reach this position here. I will reach this corner, which is, let us say, P. Okay. Then from here, I will make a displacement of Ay j cap. So I have to pick up this vector and place it over here. So I will reach from P. I will, let us say, reach this corner of the box by making a displacement Ay j cap. So I'll reach this corner Q. And then from Q, I have to make a displacement along the z-axis of Az. So I have to make a displacement which is actually parallel to this line, but from here. So I'll be making a displacement which will now from Q lead me to this point. So this displacement is now my Az k cap because I made this displacement like this. So I have reached this corner, which is, let's say, R. So what is my resultant displacement now? It is from my initial point O to the final point R. So that is nothing but this one. So if you visualize in 3 dimensions, it is the body diagonal. It's the diagonal that is going through the cube from the origin to the opposite point R. So that is my vector E. This one finally is my vector E. So this is becoming the body diagonal OR of the cube. Sorry, the cuboid. The sides need not be equal. Of sides OP, which is represented by the vector Ax I cap. PQ, which is represented by the vector Ay j cap. And QR, which is represented by the vector Az k cap. So there's sum, which is the vector E, is actually becoming this kind of a body diagonal. And therefore, the magnitude of the vector E will be square root of ax square plus ay square plus ez square, because that body diagonal geometrically will have length square plus breadth square plus width square, like this, let's say, which is okay. So visually, that is how the vector E looks now. The vector E is the body diagonal of a cuboid whose mutually perpendicular edges are of length ax, ay, and az. Okay, people, so hope this is clear. So from this point onwards, we will be working with both 2 and 3 dimensional component algebra of vectors. And when we use 3 dimensional component algebra, this is the important formula, that magnitude of A is equal to ax I cap, root of ax square plus ay square plus az square. Rest you will see that when we do sum and difference, it's a very similar kind of thing. So when we are doing algebraic operations like sum and difference, E plus B in 3-dimensional component form will just become A is x component plus B is x component I cap plus A is y component plus B is y component j cap, just like in 2D. And now to that you just add the z component. So Ez plus B z component. And similarly, if there is a minus sign in between, then here everywhere there will be a minus sign. Okay. So for example, if we have a numerical question like this, that vector E is given to us as 2I cap plus j cap plus k cap. Vector B is given as I cap minus j cap plus 2p cap. And vector C is given as, let's say, 2I cap minus j cap plus k cap. And we are asked to find E plus B minus C. We want to find out this vector. So we will just apply this concept now. So here the solution will become A plus B minus C will become A is x component, so that is plus 2, plus B is x component, which is plus 1, minus C is x component, which is my I cap. Then plus B is x component, sorry, A is x component, which is 1, plus B is x component, which is minus 1, minus C is x component, which is minus 1. J cap, okay. And then same treatment to the Z component. So A is Z component plus B is Z component minus C is Z component. That goes with K cap. So this becomes, as you can see, 1, so that is I cap. Okay. 1 minus 1 plus 1, so that is again plus 1, so plus J cap. And 1 plus 2 minus 1, so that becomes plus 2K cap. So this becomes the vector represented by this operation. Okay. And further, this becomes the answer to this part. And further, we want to find its magnitude. Okay. We want to find the magnitude of this vector. That becomes magnitude of I cap plus j cap plus 2k cap. So that is square root of the x component square plus the y component square plus the z component square. So that becomes root 6. So that becomes the mod of that. So it's basically nothing very different from 2-dimensional. It's just an additional third dimension is there in all our calculations. The rest of the thing is very simple. Okay. The main thing is understanding how to visualize the vectors in 3D and understand why the magnitude of the resultant vector becomes root of x component square plus y component square plus z component square. Okay. So people, hope you have understood this properly. Okay. And this brings us to a conclusion of today's lecture. And next time we'll pick up more examples of three-dimensional component algebra, as well as we will start understanding the couple of new vector operations, including what is called scalar product or dot product of two vectors. So if you go through your module, that is the thing which is there after sum and difference of vectors, and after the basic explanation of component algebra, the next thing is what is called dot product or scalar product of two vectors. So that is in fact what we'll be discussing in the next lecture, along with some more examples of component algebra. Okay, so thank you everyone, and that's it from my end for today. And wish you all the best, and I will send you this thing very soon. The whiteboard and the screen. Okay, bye everyone.